All right, guys, for our final example here, it says you want to approximate the average amount of chicken breasts collected from a meatpacking area. In a sample of 36 days, you find the average to be 423 with a population standard deviation of 25.4. Create an 80% confidence interval for the population average of chicken breasts collected. Well, hopefully you picked up on these words right here, population standard deviation, because that is certainly now known. So we know the population standard deviation, which means we will be using a z-chart to determine our margin of error and then creating a confidence interval with that. So this one is a population standard deviation known. So let's go ahead and start writing out exactly what we know. Well, we do know our confidence level, which is C, and that is going to be equal to 80%. Or in other words, it is going to be equal to 0.80. Okay, and as you all should know by now, that's going to be useful to us later. Next up, let's go ahead and write out our average. Remember, our average is called X bar. So let's go and make X bar, and that is going to be equal to 423. Next up, we need to write down our standard deviation. Now remember, this is a population standard deviation, so we're going to use sigma to describe it, and that is going to be equal to 25.4. Okay, that's all the information it gives us, but that's all we actually need. So what we're going to go ahead and do from here, we are going to create a z-confidence and a standard error. So let's start with the z-confidence. Now remember, z-confidence, which is z sub c, is going to be equal to, well, these are constants. We know that there's a constant for 80%, a constant for 90%, a constant for 95%, and a constant for 99%. We already looked those up a while ago. Well, hopefully you remember that z-confidence for 80% is 1.28. And if not, well, now you know. Next up, we are going to find our standard error, which is just our standard deviation divided by the square root of our n. Now remember, our n is 36. We actually forgot to write that down, didn't we? So let's go and write that down right now. Yep. So n is equal to 36. All right. So to find our standard error, we need to find, well, let's actually write out standard error first. Our standard error is standard deviation sub X bar. Okay, there we go. Nope, that came out funny. Let's try that again. So let's do standard deviation sub X bar. There we go. And that is going to be equal to, remember, it's standard deviation divided by the square root of n. We actually know what both of those are. Our standard deviation is 25.4. 25.4 divided by the square root of 36, which many of you probably already know the answer of what that is. But for those of you that don't know all of your perfect roots, the square root of 36 we can find on a calculator. There's our 36, there's our root, and it is the number 6. So we can go ahead and put that in there now. So we still have 25.4. It is going to be divided by 6. And 25.4 divided by 6, 25.4 divided by 6 is going to give us 4.23 repeating. So let's just call it about 4.23. And all of this is looking really small. Let's go ahead and make this much larger. There we go. All right, moving on. We need to go ahead and find our E, also known as our margin of error. And that is going to be equal to our z confidence times our standard error So Z confidence times standard error which is equivalent to 1.28 times 4.23. And if we multiply those, we get 5.41 approximately. And the only thing left to do is to add and subtract our margin of error to our X bar. So we have 423 plus 5.41. Well, that's just going to be 428.41. Next up, we have 423 minus 5.41. And that is equal to, let's find out. I got 417.59. All right, so we got our big number and our little number. Last thing we have to do is just write out the answer. Let's analyze this thing. So, quote, we can be 80% confident that the population average of chicken breasts, was it delivered? Collected will fall between 417.59 and 428.41. And that's it. We are done. Thanks for watching, guys.